Hello everyone, so today we are group 3 from section 11. So today we will be presenting the problem solution for question set C, question 5 and 6. So without further ado, my name is Muhammad Hazim Alim and I will start our presentation on the problem solution for question 5. So question 5 is as follow. Hamdan invested RM6,700 for 1 year, part at 8%, part at 10%, and the remainder at 12%. The total annual income from this investment was 716 ringgit, and the amount of money invested at 12% was 300 ringgit more less than the amount invested at 8% and 10% combined. Find the amount invested at each rate. So how to solve this question is, firstly we must declare our variables. So let x be the first part of our investment, y equals second part of our investment, and z the third part of our investment. So from the passage, from the first sentence of the passage, it is stated that the total investment for 3 different parts is 6,700 ringgit. Therefore, from this sentence, we can create an equation that stated x plus y plus z equal 6,700. And following the passage, from the third sentence itself, it is stated 12%, which was the third part of investment, z, was less than 300 ringgit after 8%, which was first part of investment, and 10%, which was second part of investment combined. Therefore, we can create the next equation, which was x plus y minus z equal 300. And from the entire passage itself, we can create the third equation, which was 0.08x plus 0.1y plus 0.12z equal 716. Or we can convert the equation into fraction. 2/25x plus 1/10y plus 3/25z equals 716. So from all of this equation, we have now gathered 3 equation. From this equation itself, we can find the value for x, y, and z by using the Gauss-Jordan elimination method. To start, we will change all the equation into a metric form. So from the metric form, we will change the metric form into the reduced row echelon form, or simply we will change all the digit under the first column into 0, which means 2/25 and 1 that are below the 1 digit will be changed into 0. So to start, we will changing 2/25 into 0 by substituting row number 2 with row number 1 times 2/25. After getting 2/25 into 0, we will getting the 1 at the bottom into 0 by substituting row number 3 with row number 1. Now we have the reduced row echelon form. From this new form, we can get 3 distinct equations that we can use to find the value of z, y, and x. So as you can see from all the calculation below, we get that x equal to 900, y equal 2,600, and z equal 3,200.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Muhammad Akif bin Syed Masuhur. I will be presenting the coding and its output of the first question for our project. Initially, it will ask the user to enter the inputs for each value of the matrix. Once the user has finished entering the value, it will display the matrix based on the user input. After that, it will calculate and display the value of x, y, and z. Okay, so now I will run the code to see how it works. As you can see, the answer is same as the manual calculation for our question. I think that's all. Thank you.
Assalamualaikum Doktor. I'm Salvan and I will try my best to explain the flowchart of question 5 and question 6. For question 5, we use Gauss-Jordan method. So initially, we need to declare the size of the matrix, which based on our question is using 3 by 3 matrix. So and then we need to declare the 4 variable, which are I, J, K, and N. The reason why we just equal to matrix size is because based on the question also is we using a 3 by 3 matrix, so that's the reason. So for looping B, basically it's print all the elements of the matrix. So proceed to the second part of the flowchart. So for looping C, if the condition is fulfilled, it will go to the right side, otherwise it will go to the left side. So on the right side is basically to find the element of matrix in diagonal. On the left side is to print the answer after calculate it using Gauss-Jordan method. So that's all for question 5, and we will proceed to question 6, which we use Kramer rules to solve the problem.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Norman, and I will show you how to solve the question number 6 in set C. So the question given is Nur Aisyah invested 10,000 ringgit, received in an inheritance in 3 parts. With one part she bought mutual funds that offer a return of 5% per year. The second part, which amounted to twice the first, was used to buy government bonds paying 4.5% per year. She put the rest into saving accounts that paid 2.5% annual interest. During the first year, the total interest was 450 ringgit. How much did Nur Aisyah invested at each rate? So the first step that we do is we will assume that the first part as x, which is 4% per year, is as x, and for the second part 4.5% per year is y, and z is for the third part, which is 2.5%. So the next thing is to solve the question is we need to find the equation. So the first equation is we can get from the first sentence, indicate that the total inheritance of 3 part is 10,000 ringgit. So the equation that we get from the sentence is x plus y plus z is equal to 10,000 ringgit. So the second equation is we get from this passage. It states that the first part consists of 4%, while the second part is twice of 4.5%, meaning it is consists 9%, and the third part is 2.5%. It is also state the total interest is 415. So from this information, we can get the equation like this: 1 over 25x plus 9 over 200 y and 1 over 50 z is equal to 450. So the third equation is we can get from this statement, which is second part is twice the amount of first part. So that's mean first part is x and second part is y. So we can get to x is equal to y. So we move the y into the left side and we get to x minus y is equal to 0. So for the solution, we use Kramer's rule to solve the equation. So the first thing that we need to do is we need to change this equation to in a matrix form. like this. So to solve this equation by using Craner's rule, we need to use this formula, which is the matrix of A, determinant matrix of AI divide by matrix of A. What is mean by matrix of AI is, for example, if you want to find x is from the to find x, so we just need to change all the first column here to this value, and just like this, and we divide by the determinant of the matrix, and we just find the determinant here, uh, and determinant here, and we divide, and we can get the answer is 3000. And also for the y value, we just need to change the second column, all the second column value with this value, and we just find the determinant, and we can get the value. And also for the z, we just change the third column, all the third column value with this value, and we find the determinant and divide it, and we get the value of z. So here x we get 3000, y we get 6000, and z we got 1000. Thank you.
Hello, Assalamualaikum. My name is Ahmad bin Ramli, and I will be presenting question 6. In this question 6, we will be implementing Cramer's rule to solve this problem. Here we have main function. In this main function, the matrix we will be storing the coefficient of linear equation is already initialized by in 3 by 4 matrix. And then the user will be prompted to enter the element of matrix in row. Then the matrix will be displayed, and then the matrix will be run through the Cramer's rule function that will be brief in a moment. Now let's look at the Cramer's rule function. Cramer's rule function are used to solve this equation of matrix. The matrix using CF as given in Cramer's rule. This is the coding that we use to emulate the Cramer's rule method. And then we'll be calculating the determinants. The function for determinant is here. This is the function that we use to emulate the calculation to find the determinant of the matrix. And then we have the determinant. If the determinant for first determinant is not 0, then the coefficient have unique solution. Then we apply the Cramer's rule, and then we get the answer x, y, z. And if the determinant 2, 3, and 4, which in this programming is represented by determinant 1, 2, and 3, is equal to 0, then this equation has infinite solution. And then if the determinant 2, 3, or 4, or in this program is represented by the determinant 1, 2, and 3, or determinant 1, determinant 2, or determinant 3 is not equal to 0, then this equation has no solution. Now we'll be displaying the output. Here we have the output of our problem, and the answer for XYZ is 3000, 6000, and 1000. That's all for me.
So for the question 6, we're gonna use Cramer's rule to solve the problem. So firstly, we need to create two methods, which are double let and Cramer's rules. So this is the flowchart of the main function. Firstly, we need to do is to create a two-dimensional array that we call CF. So basically, that array is used to storing the coefficient of linear equation. So and then we're gonna create a looping to notify user to enter the value of each element of the matrix. So the next looping, we're gonna display the matrix that already been entered by the user. So and then we're gonna go to the Cramer's rules method. The main function will call the Cramer's rule method. So as Doctor can see, this is the method for Cramer's rules. So inside of the method, we're gonna create four arrays that gonna hold the value of specific element of the matrix. The reason is we're gonna use all the arrays to find the determinant using the method double det. So we will go to the double det. So basically this is the function to find the determinant of matrix, and then it will return answer to the Cramer's rules method. So yeah, and then after we found the determinant, we're gonna print it. So we're gonna create a condition which is dm0 not equal to 0. So the reason is if the determinant is equal to 0, we cannot apply or use Cramer's rule. That's the reason why the condition exists. So if the condition is true, we can use the Cramer's rule. So you can, as Doctor can say, x equals to determinant 1 divided by determinant 0 to find the value of x, and same with the variable y and z, and then we're gonna print it. So else, if the first condition is fulfilled, we're gonna print this equation has infinite solution. And the next condition is if the m determinant 1 not equal to 0, or determinant 2 not equal to 0, or the m3 not equal to 0, we're gonna print this equation has no solution. So I guess after that, we're gonna go to the main function, and then the main function will return 0, so the system will end. So I think that's all for the flowchart part. Thank you.